All right, so we are Michigan Tech's Biomedical Engineering Department Senior Design Team 2, and we are presenting on our Peripheral Interventional Stent Deployment System Handle Evolution project. So we were tasked to modify an existing stent deployment system from Boston Scientific to create a new design for a handle with an improved method of stent deployment. Some of the potential improvements that could go into this include reducing the cost that is associated with manufacturing the design, making the deployment mechanism single-handed in comparison to the double-handed mechanism that is currently into the design, having a similar force of deployment to the original design, and consistently deploying up to 200 millimeters.
So the first prototype we're showing is the wheelless design, which, as the name suggests, removes the wheel in order to save material and cost on the device, and simply adds a thumb rack to pull back the middle sheath and deploy the stent.
The other design that we created is termed the Pulley design, and this works by attaching a fishing line to the end of the sheath that covers the stent, and then wrapping that fishing line around a pulley and then around the wheel. So then as the wheel is turned, the stent is deployed as the sheath retracts as the fishing line wraps around the wheel.
For our testing procedures, we began with a deployment baseline testing, which can be seen in figure A and B, which is the total retraction of the sheath. We also did a volume displacement testing for cost analysis, which can be seen in figure C. For our testing results, we hypothesized that the pulley design would have a similar average deployment length in comparison to the original handle, and the wheelless design would have an average deployment length over 100 millimeters, but would not reach the 200 millimeter mark. With our figure on the right, we can see that the pulley design was able to match similar results of the original design, and that the wheelless design was able to complete averages over 100 millimeters, but was not able to obtain the 200 millimeter mark. For our cost analysis, the pulley design had a 16.04% reduction, and the wheelless design had a 20.76% reduction of material as compared to the original handle.
So moving forward with the project, some additional work was needed. To begin with, we would like to implement force testing to our design, which we were unable to do this semester. And our preliminary model we come up with was to attach a spring scale to the end of the sheath while deploying it in order to measure the deployment force. Also, we need to continue refining both of the designs. For the pulley design, this would mean adjusting the internal mechanisms to prevent partial deployment. And for the wheelless, to increase the deployment length beyond the limiting size of the handle. We'd also like to obtain ergonomic feedback from possible users of the device. I'd also like to acknowledge our sponsors at Boston Scientific and our advisors at Michigan Tech, along with the rest of the Biomedical Engineering Department, faculty, and staff.